All right, so this is section 2.4 on functions, part 3, and this has to do with function notation and how to evaluate functions. And evaluate just means to solve. Just plug and solve, that's all evaluate means. So we're going to be focusing on this function for this entire first part of our notes. Okay, and notice it says f of x. And up until now, a lot of times your teachers have probably said f of x and y are the same thing. It's what you get when you plug in a number for x. And really in graphing, that's true, that whatever, because remember x is your input, and then once you put a number in for x, whatever results is y, your output. But the reason why we use this function notation is I can put different things in for x. So for instance, on this first one, when it says f of x, what I'm going to do is I'm going to take my function, which is 5, and then wherever there's an x, I'm just going to put a parentheses like that. Okay, so this is the same thing as what's highlighted up here. The only difference is instead of an x, I just have an open space. And what this is telling me is that I'm going to take 3 and plug it in wherever there's an x. So instead of putting an x, I'm going to put a 3 in there. And then evaluate means I'm going to solve for here. So this is what evaluate is. Evaluate is you plug it in and you solve. And you've got to know your order of operations. Even if you're using a calculator, you got to know your order of operations in order to put it in correctly, right? Always do your, remember PEMDAS, you're always going to do your parentheses first, and there's nothing in the parentheses, then you do your exponent. So I'm going to do 5 over 3 squared is 9 minus 4. 9 minus 4, I'm going to do each level of the numerator and denominator individually first, so that's 5. And then 5 divided by 5 is 1. That is the result when x is 3. So when x is 3, my y is 1. The ordered pair for this, if you had it, would be 3, 1, because x is 3 and my input is 3, my output is 1. That would be a different way of saying that. Okay. We can also evaluate with variables. So I'm going to do the same thing I did before. I'm going to take my function, I'm going to rewrite it, but instead of an x, I'm going to put a parentheses. So do this, I'm going to do a parentheses squared minus 4. And that is my original function. And I'm going to take whatever's inside this parentheses in my function notation, and it's telling me that that's what I put in place of x. So this is 3D. Now again, you're going to do order of operations. I'm just going to give myself a little more room here. I'm going to do it's in the parentheses first. There's nothing there. So now I'm going to take it to the power. Everything inside the parentheses has to be raised to that power. So this is 3 squared d squared minus 4. I want to simplify that because I can simplify the 3 squared. That'd be 9. So 5 over 9 d squared minus 4. And you might be able to stop there, but if you're really discerning, you can tell that this is a difference of 2 perfect squares. If you can factor it, you want to factor it in case there's a way that you can simplify further. So if I were to factor the bottom, it's a difference of squares, which means I'm going to take the roots. It's going to be 2 parentheses. The square root of 9d squared is 3d. That's going to go at the beginning of both parentheses. The root of 4 is 2. That's going to go at the end of both parentheses. One's plus and one's minus, and then I have a 5 at the top. And then you would look to see, is there anything I can do to simplify? Can I cancel any parentheses? And there's not. So that's as far as you can go. And either one of these would be an okay answer. But you always do want to go the extra step of simplifying and factoring just to make sure that there's nothing more that can be done. Okay, same concept. I'm going to start with my function, and instead of x, I'm just putting parentheses. And I'm going to substitute all of this inside my parentheses. So this is d minus 2. And this is not d squared minus 4. Remember, when you have a parentheses squared, that means I've got, excuse me, 2 of those parentheses. So this is d minus 2 times d minus 2. And then you're going to FOIL it or distribute. So d times d is d squared. D times minus 2 is minus 2d. Minus 2 times d is minus 2d. And negative 2 times negative 2 is plus 4. And then I still also have this minus 4 here. This is my denominator. So if I rewrite this, in combine like terms, I've got d squared. Negative 2 minus 2 is a minus 4d. Minus 4, plus 4 minus 4 is 0, so that's going to cancel each other out. So this is my answer. I'm going to go ahead and factor this to make sure there's nothing further that I can simplify. And I can take a d out of both of those, so it's d minus 4. And I can't go any further, so either one of those would be an okay answer. But do factor it and make sure that there's nothing you can simplify further. Okay, so that's evaluating with function notation. Now, this same function, okay, I'm going to find the domain in interval notation. So I'm going to rewrite the function so it's down here so we can see it. F of x equals 5x squared minus 4. This is my function. And this goes back to something we've already learned, and that's when we're finding domain and we have a rational. What we know about the rational is the denominator can never, ever, ever be 0. So it's actually a domain restriction. It's what the domain can't be, is how we define what the domain is. And this cannot be 0. So I'm going to pull this up here. X squared minus 4 cannot equal 0. I'm going to add 4 to both sides, or you could factor it. So I have x squared cannot equal 4. I'm going to take the square root of both sides to get the x by itself, but remember when you do that, the square root of 4 isn't just 2, it's plus or minus 2. And I know that x cannot be positive or negative 2. This is also called a domain restriction. Just if you ever see or hear that, okay? And the way we find the domain is by seeing what it can't be, and it can be everything else. So if I do this on a number line, all right, I have negative 2, 0, positive 2. The two numbers that x cannot be are negative 2. It can't be that, so I've got a big circle over that. It can't be positive 2, so I've got a big circle over that. And it's everything else. It's everything between those 2 points and to the right and left of those 2 points. All right? Your domain has to be written in interval notation. All right, so I just think the interval notation is easier when you do the number line graph, because then you can visually see it. I guess if you see something that's visual, that was kind of redundant, but that's okay. So I'm going from negative infinity to positive infinity. You always go from left to right. I have an arrow out to negative infinity, and I have values all the way up to negative 2, but it's a parentheses because I'm not including the negative 2. And then I start at negative 2, not including it, and I have values that go all the way to positive 2, but I'm not including it because it's an open circle. And then I pick up again at positive 2, not including it, and then I have values all the way out to infinity. And so it looks a little long, but that would be the interval notation for the domain for that given function. Okay, let's look at what's next. Okay, now given this function, identify the domain. This is just reminding us, a little reminder of when we did domain restrictions, and this time it's under a radical, and I know that anything under a radical has to be, must be positive, because you can't take the square root of a negative number. If you do, you get imaginary numbers. We're working in a world of real numbers, so it must be positive under the radical. All right, so if it's in the denominator cannot equal 0. If it's under a radical, then whatever's under the radical, in this case it's 4x minus 3, has to be positive, which means it has to be greater than or equal to 0. And then I solve for x. So I add 3, so 4x is greater than or equal to 3. I divide both sides by 4. And I know my x has to be greater than or equal to 3/4. So if I do my number line, I have 0, and I have 3/4. All right, and I'm going to use this to determine my number line. It's, as long as your letter's on the left, it points to the direction of your number line, and it starts at 3/4. Since I have an equal sign, it's a closed circle going off to the right. This is negative infinity, this is positive infinity. So if I use this to do my domain, it starts at 3/4. It's a bracket because I have a closed circle, and it goes out to positive infinity. Okay, that's my domain for that function. Okay, next function, we're gonna do the same thing. It's under the radical. Okay, we're gonna take what's under the radical, 6 minus 5x. I know it cannot be negative, so it has to be greater than or equal to 0. I'm gonna subtract 6 from both sides to get the x by itself. So I have negative 5x is greater than or equal to negative 6. I'm gonna divide by negative 5. When you divide by a negative number, you have to flip the inequality. And when you divide two negatives, that makes it a positive. So this is x is less than or equal to 6/5. I'm going to draw my number line. I have 0. And I have 6/5 is on this side of 0. I know when I graph this, it's going to go to the left. It's got a closed circle because I have the equal to sign. It's going to the left. Okay, this is negative infinity. This is positive infinity. So my domain on this one goes from negative infinity, and I have values all the way up to 6/5. Since it's a closed circle, it's a bracket, and then you're done. And that's all we've got.